Extreme landscapes seem barren but hidden within fire. Ice, deserts, and poison waters are ecosystems thriving in ways few imagine. These places look inhospitable, yet life has endured and flourished in ways that redefine the limits of possibility. Deep beneath the ocean, hydrothermal vents release scalding, mineral-rich water. They seem deadly, boiling the seawater around them, yet at their base live vast colonies of microbes that feed not on sunlight but on chemical energy. This chemosynthesis supports entire ecosystems without the sun. These microbial mats form the foundation of a remarkable food web. Towering tube worms gather in dense clusters, some over 2 meters long. Their bodies host symbiotic bacteria that nourish them. Around them swarm shrimp, crabs, and pale fish adapted to total darkness. Each species is shaped by crushing pressure, endless night, and toxic chemistry. Together, they create a hidden oasis in one of Earth's most extreme settings. At the opposite extreme lies Antarctica, a frozen continent locked beneath miles of ice. Yet life thrives. Microbes persist in briny pockets beneath the ice, enduring sub-freezing temperatures and darkness for years. They metabolize minerals trapped in the ice, waiting for light and meltwater. In the surrounding seas, animals show extraordinary adaptations. Antarctic fish produce antifreeze proteins that keep their blood from crystallizing. Seals dive beneath the ice to hunt, holding their breath for over an hour. Emperor penguins plunge through freezing water in vast groups, streamlined for a place that would kill unprotected humans in minutes. Tiny krill, numbering in the trillions, form the base of a food chain that sustains whales, seabirds, and many other predators. When the summer sun softens the ice, the landscape changes fast. Small glacial pools form across the frozen ground. Algae bloom, turning the water green and orange. Insects appear to exploit the brief abundance, and migratory birds arrive to feed. Even in the harshest winters, life waits for its moment to return. Deserts, too, are often mistaken for lifeless wastelands. With little rain, searing heat by day, and cold nights, they test every resident. Yet deserts hold intricate ecosystems. Cacti and succulents store precious water, releasing it slowly through long dry seasons. Their shapes and spines reduce water loss and deter thirsty animals. Other plants keep seeds dormant for years, sprouting only after rare rains. Animals survive through strategy and timing. Many are nocturnal, emerging after sunset to escape the heat. Fennec foxes, kangaroo rats, owls, and scorpions patrol the night. By day, they shelter in burrows, conserving energy. Insects and reptiles endure with simple tricks. Beetles harvest morning dew on their shells, and lizards shift from foot to foot to avoid hot sand. Camels, symbols of endurance, can travel for weeks without water by using fat stored in their humps as fuel. High above, in thin mountain air, life finds another path. Bar-headed geese migrate across the Himalayas at altitudes where oxygen is scarce. Their blood binds oxygen efficiently, letting them soar over the world's highest peaks. Yaks graze meadows thousands of meters up, their coats insulating them from bitter winds. Closer to the ground, alpine slopes host resilient plants and insects. Flowers bloom briefly, exploiting short summers before snow returns. Bees and butterflies feed in bursts. Lives timed to the mountain's rhythm. With each rise in elevation, ecosystems shift. Forests yield to meadows, then rocky slopes, then bare snowfields. Each layer is a fragile yet enduring world. Some extremes challenge life with chemistry rather than temperature or altitude. In hypersaline lakes and broad salt flats, water evaporates until it is denser than seawater. Most creatures cannot survive in such brine, but specialized microbes thrive. They stain the water red, pink, and green, turning lakes into surreal landscapes visible from space. Flamingos gather to feed on these microbes, their feathers tinted by the pigments they consume. Even more hostile are acidic rivers and lakes. Born from volcanic gases or exposed minerals, their waters are toxic to most organisms. Yet bacteria form colorful mats on the rocks, metabolizing the very chemicals that poison others. In some places, small fish and crustaceans endure, evolving tolerance to conditions once thought lifeless. Many exist nowhere else, proof that adaptation can carve out survival in unlikely niches. These ecosystems show that life is not fragile, it is adaptable. In boiling vents, frozen seas, deserts, mountains, and toxic lakes, life finds a way. Each adaptation tells a story of persistence and resilience. These places are laboratories of survival, testing strategies that defy expectations. They also raise profound questions. If life thrives under such extremes on Earth, could it exist beyond our planet? The icy oceans of Europa, the methane lakes of Titan, and the deserts of Mars may host ecosystems shaped by alien chemistry, just as Earth's extremes host their own. Astrobiologists study extremophils, microbes that love heat, salt, or acid, to understand our planet and guide the search for life elsewhere. Extreme environments remind us that life's limits are wider than we believed. They are not barren wastelands, but living laboratories where survival strategies are refined. Each discovery challenges our ideas about biology, resilience, and what makes a world habitable. Earth's extremes show that life is not bound by comfort. It thrives at the edge of possibility. Subscribe to explore more hidden worlds waiting to be revealed.